review of yesterday, a tangent line is a line that intersects the circle exactly once. It might go beyond the circle, it might just stop at the circle. But that would be our tangent line. It intersects the circle exactly once right at that point right there. Okay? So a tangent intersects a circle exactly once. That's what you're supposed to have already done. And also you should have learned that that tangent line is always going to be perpendicular to the radius of the circle at that point. Okay? So at the point where they meet, they have to be perpendicular. That's what makes it a tangent line. So when I say there's a line tangent to a circle, you now know that that means that this line has to intersect that circle exactly once, and that if I drew the radius from the center to that point where it intersected, that radius would be perpendicular. Okay? So that makes it tangent. And we can answer more questions on that later, but we're going to move along. I just want to make sure that you had that much information understood from yesterday. So for those at home, these are our cans for the day. So in a chord, it's a segment whose endpoints are on the circle. And so I could draw a chord anywhere I want to. That would be a chord. This could be a chord. That could be a chord. What's that?
Fantastic Four.
That's reversed.
Oh, yeah.
It's the mirror image of it. There we go.
If the Fantastic Four was.
Okay. So, for you Fantastic Four fans, we'll just switch this.
Thank you. My mind is at ease now.
I don't see the difference.
Hey, I remember mine.
There you go. Actually, maybe it's over here. All right? I didn't want it to go through the center anyway. What is it if it goes through the center?
Intersection.
Diameter. If it goes through the center, it would be the diameter. Okay? It still would be a chord. The diameter is represented by a chord, but it's a special chord because it passes through the center. Okay? But these are some chords, and if we wanted to name them, we'd have to have some letters on our circle, some points, I mean, on our circle. A, B, C, D. And so segment AB is a chord, segment AC is a chord, segment BD is a chord. Okay? Any questions on what chord is?
What was that symbol again?
What symbol?
The congruent symbol, I think.
Oh, congruent is an equal sign with a.
Okay.
You could in your notes. I'm trying to make notes that I want to keep for a while. So
Well, when we were doing,
anyway, we're recording now, so I'll read through it. Make sure you read my writing, then I'll pause so you can finish copying it down. Within a circle or in congruent circles, congruent central angles have congruent chords. Congruent chords have congruent arcs, and congruent arcs have congruent central angles. So we made a complete circle here, haven't we? Okay, so if we have congruent circles or within the same circle, then if the central angle is the same, then so is the chords and so is the arcs. They're all the same. If an arc is the same, then the central angle created that arc and the chord would be the same. If a chord is the same in two circles or two congruent circles or within a circle, then that means the central angle and the arcs are also congruent. So you can't have one of these three without having the other two also be true. Okay, so here we have a circle, and we have a couple central angles drawn. remember a central angle is an angle whose vertex is at the center of the circle. And so here's another one. If you don't have that in your head, and you don't have it written down somewhere, then you should write that down. A central angle is an angle in a circle whose vertex is at the center. Okay? So if these two angles are the same, these two central angles, then that means that let me reduce this, change color. That means then that this chord is equal to this chord. Okay? It also means that this arc is equal to this arc. Okay? So if one of those three things is true, then the other two have to be true. That's what that theorem that we just wrote down was talking about. The theorem didn't have a name, so I didn't even identify it as a theorem, but these three facts are a theorem. And simply a theorem means what?
Can be proven.
Something that can be proven. Statement that can be proven to be true. Okay? Where a postulate is something that we what?
We prove, right?
No, that's just,
I'm not sure I heard you correctly.
That we have to prove it.
No? That's a theorem. If you can prove it to be true, it's a theorem.
because the
Postulates
postulate's
already known to be
proven.
What'd you say?
already known to be true.
Yeah, well, it's accepted to be true. Okay? So a postulate is something that we accept. It's a statement we accept to be fact. All right? So that would be a postulate. Something that we can prove is a theorem. Okay? All right. Any questions on the central angle? What a central angle is, what an arc is, what a chord is, and these three statements to this theorem that they all have to be equal to each other if the circles are congruent or if it's the same circle. All right, moving on then.
I was gonna tell you your hair's not transparent.
Oh,
It's close.
my salt and pepper glistens in the light though.
Yeah.
All right.
Touch of gray just for me.
So within a circle or congruent circles, chords are equidistant from the center and, chords equidistant from the center are congruent. And two congruent chords are equidistant from the center. And so they're converses of each other, these two statements. So it's really an if and only if statement. And it means that if I drew this circle here, and I had this chord here, and I had this chord here, I have to pretend I'm doing this right. And if these are perpendicular and these are congruent, that means the red chords are equidistant from the center. Remember to measure the distance from a point to a line, it has to be a perpendicular line to that other line from the point. And so here's my center. And so to measure the distance from the center to this chord, then we have to have this blue line right here that is equidistant or perpendicular to the red line and equal to this other one over here, okay? And so if they are equal, that means that those chords are equidistant from the center. And so this theorem is saying that if they're equidistant from the center, then this red chord on the left is congruent to the red chord on the right, okay? So if you saw this picture that looked like this in the homework, and you saw this line here and this line here, what's that saying about those two red chords? They're congruent, right? And then you go from there and say, well, if they're congruent, then number 2 here says they have to be equidistant from the center. And so that would have to be perpendicular. Whoops, there. Got my elbow too close. So those would have to be perpendicular, and then the little blue segments would have to be equal. Okay? So that's what this is saying. There's 2 things there. And again, just like with the last theorem, where all 3 of them had to be true if one of them was, here it has to be true both ways. Okay? I'll move back down in just a moment, and then I'll pause so you can finish copying this. The first theorem says in a circle, a diameter that is perpendicular to a chord bisects the chord in its arcs. The second one says, in a circle, a diameter that bisects a chord that is not a diameter is perpendicular to the chord. And the third one says, in a circle, the perpendicular bisector of a chord contains the center of the chord. So I'll pause now, let you finish copying this, and we'll talk about it. So in the first one, I'll read it again. It says, in a circle, a diameter that is perpendicular to a chord bisects a chord in its arcs. So if we know this blue diameter is perpendicular to this red chord, then that means that it cuts that chord into 2 equal pieces, okay? And this arc that's created here is also cut into 2 equal pieces, okay? And so if we label that arc, we would say arc BC is congruent to arc CD. And we could say segment BE is congruent to segment ED. Okay? By the way, if you've not practiced labeling arcs, remember, if it's a minor arc less than 180 degrees, you can use 2 letters. Okay? If it's a major arc, which would be the other end of this, let me go red, I guess. And you notice in the wording it says, and its arcs. Okay? And so the other end of that diameter is cutting this other arc into congruent arcs. So we would say that arc BAD, I'm sorry. Back up. Arc BAD is cut into equal pieces, and it's going to be there's still minor arcs. I looked at the big one, BAD. That's a major arc, but arc BA is still a minor arc, and that's going to be congruent to arc AD. Okay? I started to say that wrong, but I caught it. The red arc, the big red arc is a major arc, but when you cut it in half, we get 2 minor arcs. And we know they're minor arcs because from here all the way to there is a semicircle, right? That's half of it because the diameter, the blue line represents the diameter, which cuts the circle in half. And so this green arc out here is a semicircle, and so the red arc, AD, this one right here, is going to be less than that 180 degree arc. So even though it looks big, it's still for sure less than 180 degrees, so still a minor arc. So we can still use just 2 letters. Okay? So a little reminder on how to label arcs there, and the rest of that hopefully helps you understand that first one. The second theorem says in a circle, a diameter that bisects a chord that is not a diameter is perpendicular to the chord. Okay? So, let me throw in another circle here. Here's our diameter. If I draw this arc here, and I know that it cut it in half, so that they're equal, okay? I know that it cut it in half so they're equal, then that means it has to be perpendicular. If I know those are equal, then this has to be perpendicular, okay? Let me move up and read again. It says, a diameter that bisects a chord is perpendicular to the chord. So if we know, if you're given a picture that looks like that, then you can draw this in and know that it's perpendicular. Now how's that helpful? What's perpendicular tell us?
Right angle.
It's a right angle. And we, in chapter 9, did a lot of work with right angles, didn't we? Right triangles and trig. And so in this picture, it probably doesn't help us at all, but in a problem they might give us, we'll then use that information to go on and answer the question they're asking for about. Okay? Now, you notice it said that is not a diameter. Okay? If I took this chord and made it a diameter, okay, then this would still be equal to this, wouldn't it? They're radii of the circle, correct? If they're diameter, they pass through the center. And so the distance from the center to the circle is equal on both sides, isn't it? So this is equal to this. They're no longer perpendicular, are they? Yes or no? Is the red and blue line perpendicular?
No.
No, it's not. Okay? So to make sure that it's always perpendicular, for this theorem to always be true, then this line that it's bisecting, the red line bisected the blue line, but that blue line, for it to be true always, can't be a diameter. Okay? So it has to look like that. All my lines now. There we go. Alright, so that looks a little closer. Now it's perpendicular because it's congruent. And that would also be true if I drew one right here, and I knew that these are equal, then that would mean this would have to be perpendicular. No matter where I draw it, I can draw my line here. As long as it doesn't pass through. If it cuts this into equal pieces, then this has to be perpendicular. Okay? The only time it's not, see, at least when I put my glasses on, I can see. His glasses are on, he's still going like this, trying to get the focus.
I'm going today too.
You need longer arms.
At least I got my shirt on correctly today.
Go and tell too many people about that story.
It's pretty sad, isn't it?
I'm not telling words.
Yeah.
I'm not saying words.
Spill it
You
out.
gotta say something.
He's gone.
Something like that.
He's
Shots
gone.
fired.
Spill it out.
All right.
Well,
Hey, if you notice, I have your calendar done for the rest of the month. On Wednesday, April 1st, way down here, we have a full day of school. And on Thursday, we have a half a day of school. And on Friday, we have no school. It's Good Friday. So, in case something happened in here and we got lost a day, I saved an extra day. Actually, what I did was I didn't want to get into chapter 12 before spring break, so I just went to the last day I wanted to give the test, put the test in, and I worked backwards. So you'll notice there's about 2 days just about every lesson. Okay. I forgot to write in the quiz. Probably on the 26th will be our quiz 2.
You
We have
said-
quiz 1 on the 20th. The 26th we'll have quiz 2. I'll fix that and put in. So today we're doing 1 through 19 all on 11-2. Tomorrow we're going to add a little bit of a worksheet. It's not going to be a lot of problems tomorrow because some of you need to finish, get caught up. Remember I told you though this chapter that any day I might walk in the room, or when you walk in I might say, turn in yesterday's homework, I want to give you a grade on it.
So can we just do it like the way that for every day this week the homework is due the next day?
You can plan it that way. I'm not going to guarantee that I'm going to collect it, but that's my point. You need to be prepared for that every day. I'm just saying I'm not necessarily going to do it every day. Okay?